You know, every single day, we're all relying on this vast, invisible resource. It's what powers our 5G phones, our Wi-Fi, our TV broadcasts, pretty much everything wireless. And that resource? It's the radio spectrum. But here's the thing. Even though you can't see it, it's one of the most tightly controlled resources on the entire planet.
So that brings up the big question, right? Who's actually in charge of this stuff? Who are these powerful groups making decisions about our digital world behind the scenes? Well, you can think of them as the unseen architects of our modern lives. And today, we're going to pull back the curtain.
Okay, so first things first, what exactly is the radio spectrum? The easiest way to think about it is like land or water. It's a natural resource, and there's only so much of it to go around. It's the range of frequencies that all our wireless signals travel on. And because it's so limited and everybody wants a piece of it, it has to be managed really, really carefully.
And why is that management so critical? Well, without it, you'd have total chaos. Seriously, imagine your phone call constantly dropping because it's bumping into a local TV broadcast, or your Wi-Fi going haywire because of a satellite signal. Regulation prevents this electronic Wild West, making sure all our signals stay in their own lanes so our tech just works.
So who are the sheriffs keeping the peace in this territory? The system that brings order to all these invisible airwaves, well, it pretty much operates on two levels. You've got a big global coordinator, and then you have the really powerful national players who call all the shots inside their own borders.
At the very top of the pyramid is the International Telecommunication Union, or the ITU. It's a UN agency, and its main job is to create a kind of global playbook. It helps make sure that, say, a satellite launched by one country doesn't mess with the cell phone networks of another. They set the big guiding principles for the whole world.
But here's the key. The ITU really just provides recommendations. The real power, the ability to license, auction off, and enforce the rules for spectrum, that all happens at the national level. Every country has its own authority. So let's take a quick trip around the globe and meet some of the heavy hitters.
First stop, the United States, home of the Federal Communications Commission, the FCC. Now, the FCC is a huge player on the world stage. They're the ones running those multi-billion-dollar auctions for spectrum, and the decisions they make can literally create or destroy entire industries, which makes them one of the most powerful tech regulators out there.
Popping over to India, we see a system with two main bodies, the Telecom Regulatory Authority of India, known as TRAI, and the Department of Telecommunications. Managing the spectrum here is just a monumental task. I mean, you're trying to balance the needs of over 1 billion mobile users while also pushing for huge technological growth. It's a massive undertaking.
Next, let's pop over to the United Kingdom, where we find Ofcom. Their job is pretty broad. They face this unique challenge of balancing the demand for cutting-edge mobile tech with the deep-rooted traditions and needs of public broadcasting, all under one roof.
And in China, the main organization is the Ministry of Industry and Information Technology, or MIIT. The approach there is often about long-term, state-directed planning. They allocate spectrum in a way that lines up with the country's national goals for technology and industry, which is a huge deal when you have the world's largest base of internet users.
Now, what's really fascinating when you put these side by side is how each one's focus tells a story about their country. The FCC in the US is all about auctions and 5G, which speaks to that competitive, market-driven system. Ofcom's deep connection to broadcasting really highlights how important public radio and TV have been in the UK, and TRAI's focus on broad policy? Well, that's absolutely essential for managing the sheer scale and explosive growth of India's telecom market.
Okay, so we've met the main players, but let's bring this all back home. Why is the work these agencies do so incredibly important for the tech you and I use every single day?
At its heart, their mission is this incredible balancing act. They have to make sure this limited resource is used efficiently, almost like air traffic controllers for invisible signals. They also work to create competition so we consumers have choices. And maybe most importantly, they are the gatekeepers to the future, clearing the path for new tech like 5G and whatever 6G is going to be.
And here's a perfect example of how they do it. See, regulators don't just treat all spectrum the same. They'll assign the lower frequencies, the ones that travel really long distances, to help cover huge rural areas. But then they'll assign those super high millimeter wave frequencies, which carry tons of data over short distances, for blazing fast 5G in crowded cities or stadiums. And for anyone in the field, this isn't just some abstract policy stuff. These decisions have huge real-world consequences for engineers. The rules set by these regulators directly impact how companies design everything from the smartphone in your hand to the 5G towers that connect our world.
So to put it all together, the whole system that makes your phone work is kind of like a pyramid. Way up at the top, you have the ITU, providing that global coordination. Then in the middle, you have the national regulators like the FCC or TRAI who create and enforce the actual rules. And the result, at the bottom, is the seamless wireless connection that we all pretty much take for granted.
So if there's one thing to take away from all this, it's this. A global body helps keep everyone on the same page, but the real control over the airwaves in your country is in the hands of your national regulator. It's that partnership between global coordination and powerful local control that makes our entire connected world possible. And that leaves us with a big question for the future. Our appetite for wireless data is just exploding. As we race towards 6G, the Internet of Things, and all kinds of tech we haven't even imagined yet, how will these unseen architects adapt? How will they manage the ever-growing pressure on our most vital and still invisible resource?